Next function is cos function. So we can check whether cos function is 1, 1 and on 2. Cos x. What is the domain of cos function? It is R and the range is -1 to 1. Again, is this function 1, 1 and on 2? So the quadrant, first quadrant, second quadrant, third quadrant, fourth quadrant. Cos is positive in the first quadrant and fourth quadrant. So cos, let cos pi by 4. What is pi by 4? It's 45. Cos 45 is 1 by root 2. Then cos is positive in the last quadrant, that is fourth quadrant. This is 0, pi by 2, pi, 3 pi by 2, and here it is 2 pi. So fourth quadrant value we can write as cos 2 pi minus theta. So cos 2 pi minus theta is same as cos theta. Okay. So cos 2 pi minus, here I put theta as pi by 4. Cos 2 pi minus pi by 4, that's equal to cos 7 pi by 4. That is also 1 by root 2. Isn't it? Now cos 2 pi plus theta, cos 360 plus theta. 360 plus theta is in the first quadrant, that is same as cos theta. So that also cos, that is cos 360 plus theta is equal to cos theta, that's equal to 1 by root 2. So look, cos value repeats. So is it 1, 1 and on 2? No, it is not 1, 1. What about on 2? It is on 2 for this, for every element in this set. For every element there exists a pre-image in R. So it is on 2 but it is not 1, 1, since because of this reason. The same value after one rotation values repeats, then first and fourth quadrant value repeats. So the function cos x is not 1, 1 when we take the domain as R. So as in the previous case, we divide R into many intervals, sub-intervals. So how we divide? The division is like this. The range is -1, 1. So division of R means we have to divide in such a way that we have to get all these values. That is -1 to 1. There are a lot of real numbers that we have to get. So one interval is, let 0 to pi. What is cos 0? Cos 0 is 1. Cos 180, cos pi is -1. And in between we have 90 degree pi by 2. Cos pi by 2 is 0. 0 is in between -1 and 1. And also 0 to pi. 0 to pi means the interval 0 pi. First quadrant and second quadrant. In first quadrant cos is positive, second quadrant cos is negative. So positive side we get 0 to 1 that side, and 0 to -1 that is in the second quadrant. So when we take cos from the 0 pi to -1, 1, then the function will be 1, 1 and on 2. So we can define an inverse function from -1, 1 to 0 pi. Or there are so many intervals like this. Another interval is, look, pi to 2 pi. Okay, pi means 180. What is cos 180? Cos 180 is -1. Then 2 pi is 360. Here 2 pi. Cos 2 pi is equal to 1. And this value is 3 pi by 2. Cos 3 pi by 2 is 0. And also in the third quadrant cos value is negative and fourth quadrant cos is positive. So when we define the function cos x, pi to 2 pi to -1, 1, then also the function is 1, 1 and on 2. So here also we can define an inverse. Then another function like that, so many intervals, -pi to 0, there also function is 1, 1 and on 2. But so corresponding to each subinterval we get a branch of function cos inverse. But the branch, this branch, okay, that is known as principal branch. So cos inverse is defined from where to where? Cos x from 0 to pi. 2 minus 1, 1. When we write interval here, smallest is this side, greatest one is that side. In that way you have to write. So 0 to pi minus 1 to 1 is 1, 1 and 1, 2. So we can define an inverse function. Inverse from always the second set, that is range of f must be equal to domain of f inverse. So cos inverse x domain is minus 1, 1, 2, which is the range this 0 to pi. Okay, so cos inverse from minus 1, 1 to 0 to pi. Like that, the next 4 trigonometric functions also we can define. So next one is tan. Okay, the domain of tan is r minus, set of all x is that x is equal to, tan means sin by cos, so multiples of pi by 2 we have to subtract, where n belongs to z, and its range is r. Then clearly this function is not 1, 1. Okay, so we have to, as in the previous cases, we have to divide this into many subintervals. So tan is just like sine inverse. In that way we can divide. So look, tan x minus pi by 2. If we take the interval minus pi by 2 to pi by 2, okay, to r, then the function will be 1, 1 and 1, 2. But is this one closed or open? Tan means it is sine by cos, and cos 90 is 0. So the function is not defined. So this is not closed one, it is open. This bracket is open one. Okay. So when we consider tan x from minus pi by 2 to r, the function is 1, 1 and 1, 2. Hence we can define an inverse from tan inverse x, that is from r to this interval minus pi by 2, pi by 2. Okay. Now the next is cot. Cot, domain of cot function is r minus, set of all x is that x is equal to, cot means cos by sine. So x is equal to n pi, you have to subtract, n belongs to z, to r. Again this function is not 1, 1 and 1, 2. So you have to divide into subintervals, and the interval 0 to pi. Cot is similar to cos and tan is similar to sine. So 0 to pi to this r is 1, 1 and 1, 2. Is this closed one? Again you can check. Cot x means cos by sine. Cos by sine. Sine 0, 0. So the function not defined. Sine pi again 0. It is not defined. So that is not closed one. It is open interval. So the function is 1, 1 and 1, 2. Hence we can define an inverse, cot inverse x from r to open interval 0, pi. Now the next function is cosec inverse. Cosec inverse x or cosec x. What is the domain of cosec x? Cosec x is r minus. Cosec means 1 by sine. So multiples of this n pi that you have to subtract. So set of all x such that x is equal to n pi, where n belongs to z. It's the domain, and range is r minus open interval minus 1, 1. Again the function not 1, 1 and 1, 2. We have to divide into subintervals. So cosec x is 1, 1 and 1, 2 in the interval minus pi by 2, pi by 2. Okay. Here it is closed interval, cosec means 1 by sine, sine pi by 2 is defined. But in this interval we have a point 0. Cosec means 1 by sine, and 1 by sine, when we put x is equal to 0, 1 by sine 0, that is not defined. So we don't want this point in this interval. So that you have to subtract from this, the number 0. Okay, so this is the domain of cosec function to r minus 1, 1. So this function is 1, 1 and on 2, hence we can define an inverse, cosec inverse from r minus 1, 1 to minus pi by 2, that is closed interval, minus the point 0. Then the last one. So cosec also, look, cosec also related to sine. Sine, tan, cosec, they have minus pi by 2, and cos, cot, and the last one sec, they are related. So sec x, domain is r minus set of all x such that we have to subtract 1 by cos multiples of pi by 2, x is equal to 2n plus 1 pi by 2, where n belongs to z, to r minus 1, 1. The function is not 1, 1 and on 2, we have to divide into sub-intervals. So the interval we divide like this, 0 to pi. Okay. It also closed. Sec means 1 by cos. Cos 0 is defined. Cos pi also defined, so no problem. But here in between we have the point pi by 2. 1 by cos x. When x is pi by 2, it is not defined. So that we have to subtract from that interval. So minus pi by 2 to r minus 1, 1. So here this is known as principal branch. We have so many branches corresponding to each sub-interval, we get a branch of sec inverse function, but this branch is known as principal branch. So sec inverse is from r minus 1, 1 to 0 pi minus pi. Okay. So what you have to learn is this table you have to learn. Domain and range of inverse trigonometric functions. First one, sine inverse. The first you have to learn the domain and range. That table also you have to write in the notebook. Next you have to write this in the notebook. Sine inverse, it's from minus 1, 1 to minus pi by 2, pi by 2. Cos inverse from minus 1, 1 to closed interval 0 pi. Tan inverse from r to open interval minus pi by 2 to pi by 2. Cot inverse is r to open interval 0 pi. Cosec inverse is r minus 1, 1 to closed interval minus pi by 2 minus 0. Then sec inverse is r minus open interval minus 1, 1 to closed interval 0 pi minus pi by 2. So this one you have to learn. Now look at the graph of sin x and sin inverse x. Sin x graph, sin 0 is 0, 90 is 1, 180 is 0, 270 is minus 1, 360 is 1. The left hand side. Here sin inverse x. So x axis minus 1, 0, 1, y axis pi by 2, pi 3, pi by 2, like that. Then again we plot it. Actually these are mirror images. Sin x graph and sin inverse x graph. Now this same way look cos x and cos inverse x. Cos 0 is 1, cos 90 is 0, cos 180 minus 1, cos 270 0, cos 360 is 1, the left hand side. Then it is the mirror image. Okay. Similarly, the next 4 trigonometric functions graphs that is in the textbook, you just refer that. Now, look children, sine inverse x and sin x inverse. What about these two? Are they equal? Not equal. Sin x inverse means this is 1 by sin x. Sin x raised to minus 1 means 1 by sin x. But what is the meaning of this sin inverse x? It is the inverse function of sin x. Okay, so these two are not same. Then in the problem session we have to find the principal value of inverse trigonometric functions. That is, the value of inverse trigonometric function lies in the principal branch, that is known as principal value of inverse trigonometric functions. So, the value of inverse trigonometric function which lies in the principal branch that we wrote in that table now, that one. So, that is known as principal value of inverse trigonometric functions. So, if it is not mentioned in the question, then also it is understood you have to find the principal value, because we have several intervals in which the function is 1, 1 and 1, 2, but we consider those intervals which has principal range or branch of principal value. So, that only you have to consider for doing problems. Okay, thank you.